In this video, we'll be looking at the basics of how to evaluate logs, as well as some basic properties of logs, in addition to the ones we've looked at previously. So our first step is asking ourselves, how do we evaluate a log function? How do we take something and identify exactly what this is going to equal to? Well, the most appropriate way to better understand how to evaluate this log is to first remember what it really is. Every log function of this form is really equal to an exponent. In this case, I'm going to label that exponent as y. It might not always be beneficial to do this, but at least for the first couple, to get the idea of what's going on, is to force this to happen. So I'm going to go ahead and first convert this from the log function into its exponential form. Keep in mind that, again, this is the base, and this right here is the exponent. Every log is equivalent to an exponent. So I have a base of 10 with an exponent of y equals to 100. Now I'm going to ask this question, and this is the question I actually ask, even ignoring any of the extra work that I've done. Ready? I'm going to ask the question in this way, and I'm going to show you how it compares with the function over here. What power of the base gives you the inside stuff? So over here in the converted form, what power of the base, what power of 10, will give you the inside stuff? What power of 10 will give you, in this case, 100? And again, that's the question you want to ask yourself. What power of the base gives you the inside stuff? So anytime that you're looking at a log function you're trying to evaluate, you're going to ask yourself, what power of 10 gives you 100? And this logarithmic expression is actually equivalent to 2. The value of y in this case should be 2, because 10 to the power of 2 gives you 100. So it's going to be really helpful if you understand your exponential rules before getting too in deep with the log rules. If you don't know your exponential function rules or your exponential expression rules, then these things are going to get really nasty really fast. Let's look at another example. Log base 5 of 1 over 125. Now, the way that I'm going to deal with this is I'm still going to ask myself the question, what power of 5 will give me 1 over 125? Well, there's a couple of ways you could evaluate this particular function. What's probably the best idea is to start by just manipulating this inside function, or in this case, this inside number. This is the same thing as log base 5 of, well, the fact that there's no 5 in here other than the 125 causes me a little bit of problem. So I'm going to change this to be 125, specifically to the power of -1, because I'll recall that any fraction can be converted into a whole number just as long as it has a negative exponent. Again, I can flip this fraction as long as I put a -1 in the exponent. The next thing I'm going to do is I'm going to ask myself, is there a is there a power of 5 that will provide me with 125? And there is. If you think about it, I know that 5 times 5 is 25. 5 times 25 is 125. So if I do 5 to the power of 3, don't forget that that -1 is still on there, then I can convert this 125 to the power of -1 to 5 to the power of 3 to the -1. And then I can convert that one more step further as log base 5 of 5 to the -3. So the question then still remains, what power of 5 will give me 5 to the power of -3? And I hope that if you take a few seconds to think about it, the answer is going to be duh. Because 5, what power of 5 gives you 5 to the power of -3? It's in the phrasing. 5 to the power of -3, what power of 5 gives me this? Well, it's going to be that power, -3. So this should hopefully start defining some basic understanding of how the log functions can work. Now, if you still struggle with this concept, you can always set this thing equal to a y and convert it to exponential and try and work through it that way. So the base is 5, the exponent would be y, and it's equal to 1 over 125. And the goal, one more time, is to convert this thing, very much like we did all the math here, to 5 to the power of -3. Then the exponents have to be equal to each other. So in this case, again, the goal is what power of the base gives you the inside stuff. Let's look at a couple more examples. Log base 36 of 6. Now this might be tricky to understand because, again, remember, you're asking what power of this will give me this. Some of you might be able to pick it up relatively quickly. Some of you might take some extra work to identify it. If it helps, again, set this thing equal to y and convert it. 36 to the power of what will give me 6. And then it's going to be, well, how do I manipulate this to make it work? Well, if I'm working with the exponential function rules, I can convert this 36 to be 6 to the power of 2, all to the power of y. Notice how in this form, I'm not working with this side, I'm working with the base side. Yes, I can manipulate these as long as I manipulate them appropriately using the exponential rules that I know to be true. So I'm going to have this is equal to 6. If I manipulate this a little bit further, I know that the 6 to the power of 2 times y, because power to a power, I can multiply those powers. And then I have 6 to the power of 2y equals to 6. This is technically 6 to the 1. It's important for us to know that because once I've seen it like this, I can actually convert this thing to be, well, if it's 6 to the power of something equals 6 to the power of something, then that something better be equal to that other something. If the bases are the same, I can drop those bases and just look at the exponents. And therefore my y has to be equal to, solving this like a linear equation, 1/2. Knowing that y equals to 1/2, I know that what power of 36, and again, I'm going to return to that same phrase, what power of the base, what power of 36 will give me 6. Well, let me check here. 36 to the power of 1/2. Well, power of 1/2 is really just a square root. So 36 to the power of 1/2 is the square root of 36. The square root of 36 is 6. And sure enough, this y value right here, this log function or expression right here, should be equal to that 1/2. Again, the goal of these things is to evaluate the log function without necessarily having to go through all these steps. But if we don't fully grasp the understanding and the concept, then without going through all these steps, we're going to get lost in kind of a bit of the work here. So the last one we're going to look at is this right here. And again, this one I would argue should be relatively straightforward, but might be tricky to grasp if you don't remember that a 1/2 power is really just a square root. In this case, I have a 7th root. So this is the same thing as log base 3 of 3 to the power of 1/7. And that's, again, all inside there, inside that log function. And so the question again remains, what power of 3 gives me 3 to the power of 1/7? Therefore, it's just 1/7. And that's how you're going to evaluate, again, these basic logarithmic expressions, such that you have to ask that question. What power of the base gives you the inside stuff? If I tackle on this concept, this is one sentence you have to know. The other sentence you have to remember from the previous video is every log function is equal to that exponent. If you've got those two phrases down, the majority of the concepts in this section hopefully come relatively naturally. So, with all that being said, let's look at basic log properties. We covered a few of them already in previous videos, so we're not going to cover those again, but we're going to cover the more appropriate ones where they're really, really basic. Log base b of b should be equal to 1. And again, notice how that b right there is a little bit lower than the other one. This one is the one that should be level with the log function. So what power of b gives me b? Well, it's 1. That should make sense. It's the same rule as b to the power of 1 equals to b. If we look at another one, log base b of 1. Now this one might be a little bit tricky, but let's, again, grasp the concept. What power of b will give you 1? What power of b will give you 1? And there's only one power of anything that ever gives you back 1 in exponential form, and that power is 0. So this should be equal to 0. So log base b, if the 1 is on the inside all by itself, we should end up with a value of 0 for that log function. A couple more rules for this. Again, we've already covered them, but I'm going to write them here just to make sure. Log base b of b to the x is equal to x, as well as, so we've got these two here. I'm going to group them together, and I'm going to group these two down here so it's clear. The other one that we have is b to the power of log base b of x also equals to x. And again, these two rules down here are the inverse function rules. Substituting in one function into another should eliminate the functions entirely.